All right. Hi, everybody. Welcome to the meeting on 4th of June. I just posted the new issue and some comments about the last meeting we had. Chris, you weren't there, but it was mostly about the tox issue.
Yeah.
And Alex from the School of Pharmacy had posted some data on her analysis of the tox, and the tox looked like it was pretty uniform across the molecules. So we didn't see, the lower toxicity for the molecule that Laurie saw low toxicity for, although of course the assay is different. So we were trying to figure out, well, how serious is this, and roughly how bad are the data? Are they terminal or are they okay, and we don't need to worry, or is it an artifact of there being lots of different assays in play here? And so, and Ed and Dana and Anthony, if I've got any of this wrong to say, because I'm trying to remember from the last meeting because I haven't watched the recording. And so I think the basic what we did is we thought is there a gold standard tox assay that we should be using for an antibacterial series? Are we all basically right, or are we all missing a trick, or which one should we be using? And I emailed Mark Blaskovich from COAD to ask, well, what do they do? Because of course they've examined a huge number of series here, and they said, well, as I've just paraphrased in the issue, there is no gold standard. They use HEC298 and HepG2 because they're from organs that are often associated with antibiotic toxicity, and the output of the assay can be very variable depending on how you run it. But generally speaking, they said, if they see toxicity at a similar level to the antibacterial activity, they carry on, which is where we are pretty much.
I guess in a way that makes sense, because there are some drugs like the fluoroquinolones, for example, that are somewhat cytotoxic or pretty cytotoxic. So it would make sense, I suppose.
Yeah, I mean, yes, I think a thing that was being highlighted by him was that often you don't get good correlation between in vitro toxicity and issues in vivo, and that's a very general statement, but essentially that's why the bar is quite low here. Because you just don't know. And he was saying that the more rigorous criterion for toxicity is about red blood cell hemolysis, which was evaluated
for the series. Is an issue with some antibiotics like vancomycin, for example.
It was evaluated in the series before we started, and it was seen. They see 10%, so they didn't see the sort of artificial bar of 10% hemolysis at the MIC. So seen as sufficiently promising to carry on. Now, that doesn't solve the problem of us having a bunch of data which suggests reasonable toxicity, but it isn't at the moment a sort of killer red flag, I guess. Have I got that roughly right based on the people who were at the meeting?
I mean, I don't expect these compounds to cause hemolysis because red blood cells don't have a nucleus. They don't have DNA.
Right, but you're making an assumption there, obviously.
Yeah.
I mean, anything that many compounds can cause hemolysis just because of their physical chemical properties. Anything that disrupts membranes or anything like this will cause hemolysis.
Yeah, it's quaternary salt would, but
no, there's lots of compounds that are just amphiphilic.
But we're relatively a compound slightly basic, I think.
Yeah, but Chris, lots of different ways in which it can happen.
Yeah.
So, I mean, the short story, so Alex is finishing off her analysis. She had an incomplete table of data, which is fine. So from a publishing perspective, we need it to be complete. So we have one analysis done by one person. There's a complete set of data, which is good. So she'll continue to do that. She's willing to look into whether or not there is an apoptosis mechanism of action, I think it was, where we left it.
Yeah, so I looked into this a little further. So there's this master switch kinase called ATM, which is activated during DNA damage. So what she should do, or what I've seen people do in papers, is they have a specially made antibody that's already pre-made, easily bought. It's been labeled with a fluorophore, and it binds to the phosphorylated ATM, which gets tripped when there's DNA damage. So I think that's what's going to happen. I'm not sure. Maybe follow up with Alex on that.
I'll forward her the issue. I think you posted.
Yeah, antiphospho ATM fluorescence microscopy is the kind of generic way to see if, or is this really damaging DNA?
Then subsequent to the meeting, Laurie posted, you just joined, right? Oh yeah, Laurie just posted a comment. So this is on the bottom of issue 72, around compounds for which they got PK. Laurie, did you just want to mention the significance of this?
So I thought that actually the follow-up comment from Ben was really helpful, and he pointed out a couple of points in there that I didn't capture in my comment. I guess I really wanted to highlight this. So thank you so much for posting that link, Matt. So the thing that I found most interesting about this, the two compounds on the left, so 3579400 and the one ending in 3576. From MRC5, both of those were seeing low micromolar toxic, or what we would call toxicity. And yet when they went into PK, neither of those compounds actually were toxic in the PK model. We saw no signs of toxicity. Look, full disclosure, exposure wasn't super high. It wasn't high enough for us to progress into the efficacy study. Whether that means that our exposure just wasn't high enough to have enough compound available to be toxic or to see toxicity, that could be one thing. We did also, though, like co-dose these with ABT as a CYP inhibitor, just to see if that would also increase the exposure. It did, but not to a level that we were happy to progress into the leash efficacy study. So I guess I found this interesting because it comes back to that point you made, Matt, earlier about in vitro translating to in vivo tox. Is MRC5 the best cell line to look at in terms of the tox? Maybe not. When you think about 3575, that has a better tox profile overall compared to the other two. That one was the one that we did see adverse effects in the PK. Our exposure was also higher. There was a question mark, as Ben mentioned, in terms of whether it was the ABT that was kind of contributing to that as well. So, yeah, I mean, I think there's still a question mark about the series as a whole. I think that for me, this data, this information kind of suggests that we should keep going and don't jump ship just yet, just because.
Proceed with caution, maybe?
Sorry, what was that?
So basically proceed with caution.
Yeah, look, I mean, I think once we actually get to the point where we've got something that looks really interesting and then we go into a PK with it, well, at that point, you know, we'll have an answer as to whether or not tox is really an issue for the series as a whole. I mean, yeah.
Yeah, it is interesting, isn't it? I mean, it's a complete lack of correlation for those three compounds.
Yes.
We have quite a
just to make sure I've got my nomenclature right, the compound that Ben mentions with the imidazole 4-yle group, he's talking about the group with the nitrogen in the essentially the ortho position, which could 1, 2, 3. I'm just trying to figure out where that is. I'm trying to remember my.
So
is that with a chelating motif?
So you replace the pyridine with the imidazole. Is that?
Yeah, and the nitrogen is Is it collating?
Right, sorry. Ooh.
Trying to think of where, if it's next door to, if there's a nitrogen next door, I guess there must be.
Let me
If it's,
just confirm. I think it is.
So if I hate nomenclature, but you got the NH, you got the carbon, you got the N, and then you got the attachment
a
point.
wonderful thing called opsin, which parses nomenclature into a structure file.
Yeah, no, sure. There's no excuse as being chemistry professor not knowing that.
I'm just going to pull up the structure just to triple check.
Yeah, I think that's right, because the
Yeah.
amidazole's got nitrogens at the 1,3, right? So
1,
then
2,
if
3, and then
you're
it's the next one.
attaching at
Yeah.
the 4 position, it would, yeah.
And the only thing I can't remember is whether the 1 is where the yeah, it's potentially collatable, but it depends on where the H is.
It can tautomerize, so
So it doesn't really matter, right? But it's got the
Yeah.
potential to be collating.
yeah.
Yeah. I mean, yeah, because of course those, yeah, okay, fine. Yeah, I mean, the overall message is that we can kind of ignore all the tox data we got, which makes you think, why are we doing it in the first place?
The problem is, of course, then that you're deciding whether you have any tox is an in vivo assay, which is expensive to do and
Undesirable.
yeah.
Well, we have built-in funding for a PK study for the series, right?
Yeah.
Yeah.
So I think that, you know, and then that would tell us whether we have in vivo tox as well. So I think my takeaway personally is that, you know, even though we're seeing this tox, I think that shouldn't stop us from trying to at least get a compound into the in vivo PK study. And then that will give us some more reliable data to go on.
Because, as I said, fluoroquinolones, for example, are somewhat toxic, but most people, not all people, but most people tolerate them okay. So I wonder if that's almost similar to what we're seeing here.
I think
Did somebody
things
share
are
something?
too.
Sorry.
Yeah, I shared the structure of that.
Yeah.
Compound.
Oh, sorry, I missed it. Sorry, I missed it.
Oh,
Sorry.
It was as
This
we
is it.
thought.
Yeah.
Yeah, there it is.
it's like a metal binder. And this was not that toxic in vivo?
Yeah, that one. What did Ben say again? Good exposure, no adverse events. That one was looked at for Chagas disease. The only concern there was that it's also a T-cruzy CYP inhibitor, which is a no-go.
T-cruzy CYP inhibitor. Was that one of the Finaraballs?
No.
All right. So I guess we proceed as planned with the synthetic targets. I mean, and then get a full picture of the SAR and then make a call. I think you're right, Dana. I mean, we do have the ability to pick a compound, and so we should bear that in mind. And maybe based on the next round of potency evaluations, that might inform which compound we're choosing there.
Yeah, I mean, I think it's still good that we've kind of done our due diligence with the cell line tox.
Yeah.
So, yeah.
Okay. So yeah, Alex is working away on that. We can invite her back when she's finished to tell us about it. I've asked Paul Stapleton for an assay slot, and I'm waiting to hear back about when he can evaluate the next compounds. And then I didn't know if anybody wanted to update on chemistry. So Flavio can't join us, but I know he's beavering away on the chemistry in his lab. Did anybody have anything they wanted to say about compounds that are being made? I didn't give anyone any warning, so no worries if there's nothing. No?
I was going to kind of get back to the one-pot reactions with the 5-membered rings that are on our list, and try and get enough of the alkylated and the unalkylated versions of those.
All righty.
I know that chemistry at Northeastern has begun. We had some issues getting one of the reagents in, but that's now in hand. And so we're actually just trying a couple of different routes. What we found historically with the analkylation chemistry is that we get a mix of mono, di, and tri-alkylated materials, which are really challenging to separate, even by reverse phase. And so we're also changing up the order and actually putting that in first and then trying to do a Buckwald to get the 4-fluoroaniline like portion installed. So that's happening. We haven't got too much progress unless Jyoti wants to say something. Acknowledging that I've put her on the spot too there though.
Hi. So yesterday we put bookward reaction. So might be today we will get the result. And depending upon that, we will check like how we will change the route. Yeah.
Great. All right, that's fantastic. Great. One moment. I just had, so on the issue that I just posted, so Flavio did comment about where should he post experimental procedures and data of synthesized compounds. So that's on the issue I posted just now. What should we do with that? So I don't know if, I mean, the thing to respond there is, the thing to say there is that if he has a lab notebook, he can put it there. If he doesn't, then what should we do with that? We've got GitHub we can use as a lab book in a very crude way, if people want to post things there or to their own lab books, or I don't know what do you think is going to be the best solution? Let's say he's making 5 compounds. What should we do with that? We can provide guest access to lab archives because we have a license. What's the best solution, do you reckon?
Could you post an issue with the structures and then attach a Word doc with the experimental, or
Yeah, I can do that. It's just poorly machine readable, that's all, but we can probably deal with it. So difficult to find it, We'd always talked about having an issue per molecule, on GitHub, see if it works as a lab notebook and just posting smiles and stuff there and then dumping everything. Which should probably work, actually, if you're happy with the idea that it dilutes things a little bit. Or we post it somewhere on our own lab book and just link out to it. That's a possibility. But I guess we could look into getting, if Flavio doesn't have an ELN, we could look into getting him in a guest account. That's always possible, right?
If we put them into the OSA spreadsheet and have a link to, if he uploads his experimental to GitHub, would that work?
Yeah,
okay.
It would. I guess I'm thinking of, because I don't know if he's got just a Word file and then a bunch of data sets like essentially FIDs that he's just got, or whether he's got has he got a bunch of data or has he got a write-up? I guess that's the thing I'm not sure about. So we can clarify that.
You don't have to have an issue for every compound. Couldn't you have an issue being a lab notebook?
Yes, it would be very big. Yes, you could.
Yeah, and then just have people add to that. Each edition would be just a new page or a new compound.
Yeah, it's certainly possible. I kind of hope that there was a way of using projects as well on GitHub as doing this, that you could set up up at the top where it's got issues and pull request actions, it's got projects. Yeah. And I wondered if you could use that as a way of keeping something together. I haven't tried it yet. But I don't know. So I think I'll try and reply to him, but if people can chip in with advice on something, that would be really good. Also, I don't remember I wonder if somebody else remembers what Flavio said about testing. Did he mention that he was going to get them tested locally, or is he going to send them to us to get tested? I forget what he said. I think he was going to send them to us, right?
I think so.
Yeah. Okay. Fine. That's fine. I think that's what he's implying. So I think he's going to have some compounds soon to ship out, which is great.
Cool. I just sent a follow-up email today also about those amids because I realized I hadn't heard anything back from the finance guys when we tried to order them. So I just gave them a little nudge.
Yeah, great. Thank you. It was just a clerical thing, right? We're going to be able to order them. It was just a credit card issue, I think. Okay,
Mhm.
that's good. And then Ed, the metabolite. You're done, right?
Yeah. That's
Okay.
done.
Do you want to just to update people?
Well, yeah, I mean, it's hydroxylated on that methylene group in the bottom, which is what we predicted, I guess.
And you got the
found
data somewhere?
Yeah, I do have all the NMRs. I've not uploaded them yet, but can do.
Can you stick it on? Yeah, I mean, you stick it on the issue, right? You can stick it
Yeah.
there. Okay, and then just highlight the evidence that which shows the change. That would be great. And the amount you got is like a meg or something, right?
Yeah.
So A, I mean, we can't chemically mess around with that.
I found something that could potentially allow us to abiotically make more of this. Ed, the reagents are very cheap. Do you still have the parent compound? How much do you have?
We've got a lot of it because we made more for.
Could you
ISO.
take like 20 megs, put it into DCM, add 6 megs of MCPBA, you know, and see what happens?
Well, the question is whether it's worth it. My question was whether or not that compound is. Do we care if it's active?
So the last time I tried an oxidation with MCPBA, it gave the N oxide. That was when I was trying to do the sulfur oxidations. So yeah.
Sorry, just remind me, how much do we send to Paul for potency evaluation? Like 2 megs or something?
Yeah, like 1 to 2, I guess.
So if we had if we committed the whole milligram for potency, we could get a potency evaluation on the metabolite. Is that I don't know if that's interesting. I just don't know if that's actually relevant or important to know. I mean, I guess it's useful to know always, isn't it, if a metabolite is active. Chris, you know more about this than I do. What is there? The advantage of having a metabolite evaluated is that you don't care too much about the clearance rate so much because you actually want to produce a different molecule.
Well, I mean, it's a variety of reasons you might do it. One is for a developmental thing that you need to know all the information on all the things. It could give you an extended duration of action, perhaps.
Yeah.
And if it's a metabolite that actually builds up, it tends to suggest that it might be more stable.
Yeah. Okay.
Do you think, I mean, because it's such a small quantity, maybe on a very small scale, you could try different oxidants and see if any of them make it? Or is that a lot of NMR? What?
I don't think it's worth it on what I have.
No, I mean, if we have the characterization data for it and we're done, then I don't see a problem with sacrificing it for a potency assay.
Yeah, I'd agree with that.
Yeah.
If it
It's
turns
a
out to
one-way
be super,
street, you know.
yeah, if it turns out to be super potent, you'll be more than willing to go back and make more of it.
Right, there's your incentive.
Yeah.
I mean, that's true. We could probably.
And how? Okay, but are we able to accurately assess how much we have? I mean, if that like a milligram, we need to know roughly how much we got. Can we accurately assess that?
Yeah. So I mean, it's weighable out. So
okay.
Yeah.
Way outable.
Wait. Yeah.
Okay. Okay, great. I think that would be a good use of the compound and getting extra value out of the fact that it was quite a large scale procedure in the first place. So there's a reason for doing it. Okay, that's great. Well done, Ed. That was a campaign. All right. I think that was everything I wanted to mention because we've covered everything I can see there. Anyone have got anything else they would like to report or ask or mention?
I didn't totally hear about the amides. So they are commercially available. You said you can get them.
Yeah, it's just a financial glitch, and that's all. We just got to push it through, but we'll get them.
Do we have any idea when the next potency, the next SAR eval will be? Next potency eval.
No, I'm guessing next week maybe.
Okay, so I guess we're done.
Should be okay. It depends when Paul is next in. Where the building is very mixed occupancy at the moment, so it's all of it. Can't just come in whenever you want, still. All right, well, good then. In that case, I'll try and
Okay.
post the recording and action items and stuff.
Okay, that sounds good.
Great, nice to see everybody. Thanks for coming along.
All right.
Thank
Bye then.
you.
See you again soon.
Bye, everybody.
Bye.